Okay, now dative bond, or we call coordinate bond, is actually a type of covalent bond between two atoms in which they are talking about the shared pair of electrons are originated from one atom only, like hydroxyl ion and ammonium ion are two examples of ion with dative bond, like this one, ammonia. Okay, so the ammonia will share the three electron with three what you call three hydrogen. Sorry, for this one is he share this one, nitrogen share this one. You remember I tell you before, there are some bond that share without, normally with hydrogen ion. So both electrons are from nitrogen. So when he combined with hydrogen ion, so it becomes like this. You see this one. See, this is called dative bond. So means that the electron inside the dative bond only come from one atom only. Okay, normal covalent bond are like they are sharing pair. I share one, you share one. Dative bond is you share two, I never share anything. Something like that. Normally is the combination of atom molecule with ion. Okay, like this one is hydrogen ion. Okay, can you understand? Like ammonium become ammonia. But because this already have plus, even though they bonded the bond, still this one will have a positive charge. One. This positive charge come from hydrogen ion. Okay, because you cannot change the original or the initial what I call it, the initial characteristic, because you cannot neutralize it by sharing bond. But because these two bonds are not shared, so you are like borrow from them. So that's why you still lack of electron. You understand? So which one is more, you think is more stable? Ammonium on the right side, or the ammonia? Which one has a more stable structure? No, ammonia. Why? Because this is the normal way, right? And the nitrogen has already fulfilled all the outer shell. All right. You see, 2, 4, 6, 8, 9. But if you add this one inside, this one still ionized. Ion is not stable. So this compared to ammonia, ammonium is more unstable. Okay, let's say the hydrogen, there is a positive charge, correct? So positive charge means that it will tend to receive an electron, correct? To balance it out, correct? Now, although this one is fulfilled, there is a dative bond here, but this hydrogen still positively charged, correct? When there's another hydrogen come here, and another hydrogen atom comes in, this one will, when there's let's say a negative ion comes in, like chlorine ion, chloride ions comes in, this hydrogen will tend to break and combine with the chloride ion to form HCl, correct? So this is why it's more unstable. With charge, is not stable. Neutral is the most stable one for molecule or ion or compound. Compound means that more than one or two element. So compound with neutral charge is the most stable one. So if there is a charge, no matter positive or negative, for not stable. This is why this one is neutral, this one is not. So that's why this ammonia is more stable than ammonia. Okay, can later on when you learn in the nitrogen cycle, you will find out that After nitrate is formed, the nitrogen fixation bacteria will fix it into ammonium. Then from ammonium, it will become ammonia. Why it become ammonium? Because ammonium is not stable. Okay, all right, jot this down. Don't draw this one. This one doesn't look so not so how to say not so clear. That's why I copy another one and paste it here. This is actually the one that I show online. This one is I draw myself, but because my drawing doesn't show clearly, that's why I copy this one. Okay, jot this down. Done, huh? Good. Now let's continue. So you see from this diagram 5.2, it shows the formations of dative bond in hydroxonium ion, which is H3O. H3O is you should get a positive. Okay, so you see normally in water molecule, the H2O oxygen atom, the oxygen atom O and hydrogen atom has a stable duplet and octet electron arrangement, correct? Duplet for hydrogen, octet for this what I call oxygen. Now, the hydrogen ion, that this one is a hydrogen ion, so it does not have any electron in the shell. So what happened is the lone pair electron in this water molecule here. This is the lone pair. Lone pair means that it's alone and not joined to any element. Okay, so share with the hydrogen ion through a dative bond, so it becomes finally like this. In hydroxonium ion H3O plus, so the oxygen atom O and the hydrogen atom H, okay, have a stable duplet and octet electron arrangement here. So this one is the dative bond. With this, it seems like the oxygen has what you call, the oxygen has a, we call this as a octet electron arrangement, while this hydrogen, sorry, has a duplet electron arrangement, but it still maintains the charge before they join, which is positive. So that's why H3O is positive. Okay, can the oxidation number is 1, positive 1. Okay, so jot this down. Okay, now let's see the next one. Huh? So now, based on this diagram, you see, let's see the formation of ammonium ion through the formation of the dative bond between the hydrogen and nitrogen atom, hydrogen ion and nitrogen atom. So, okay, always the first one when you try to explain, the first sentence we need to mention that the hydrogen ion does not have any electron in the shell. So, and the nitrogen atom in ammonia has a lone pair. After the hydrogen ion, after we talk about the ion, then we need to talk about the lone pair. So has a lone pair that can be shared with hydrogen ion. So the sharing of this electron forms the dative bond. So this is how you should explain it. Can you understand? The ion does not have any electron at the valence shell. Then we need to talk about the lone pair on the nitrogen. Okay, so means that the way of we discuss is first the electron. Okay, we need to talk about the no electron in shell for ion, for hydrogen ion. Okay, then after that we say nitrogen. We need to talk about the nitrogen lone pair. Okay, lone pair electron. And then they form active bond. This is how you should answer. So 3 to 4 marks up. If withdrawing, maybe 4 to 5. Okay. Can I? All right. Now, if that's the case, try 5 point. Try this 5.5. Okay.
For question, I want to explain the three molecules. The ammonia molecule and the molecule integrated and then ammonium molecule. I want to explain that three.
No. You just explain the atom that involved in the active bond only. Like this one is the bromide and boron and this nitrogen. So you just need to mention the nitrogen from ammonia and the boron from boron trifluoride. Like that. Nana? All right, so let's see the answer. Now, first, what's the meaning of this dative bond? So it's a covalent bond between two atoms in which the shared pair of electrons are originated from one atom only. Now, based on this diagram below, explain the formations of dative bond between the ammonia molecule and boron trifluoride molecule to produce the ammonia boron trifluoride. So now, like always, First, the lone pair electron at nitrogen atom in the ammonia molecule contribute to boron trifluoride molecule to be shared together. So the sharing of electron forms the active bond. Like always, we need to talk about the lone pair because this one doesn't involve ion. So it doesn't mean to mention about the ion. Okay? Okay. Done, huh? All right. Now let's see metallic bond. Okay, metallic bond is quite usual one. It's actually between the positive ion of metal with the covalent, with the negative ion of non-metal. So normally, metal atom has 1, 2, or 3 valence electron. Okay, 4 like carbon, we are not considered as metal anymore. We are called metalloid. Means that half metal, half covalent. Okay, so normally the outer shell is only 1, 2, and 3. So only group 1, group 12, and group 13 are considered as metal. Okay, so in solid state, the atom of metal are arranged closely like this, and in orderly manner. Sorry. So even in solid state, the valence electron of metal atom are easily donated and delocalized, and the positive, because although they are in solid state, but the valence electron are easily to donate. Why? Because although it's solid, it doesn't move, but the electron can move, is freely move freely in this state, so it can be easily donate. Donate means release. Okay, and delocalize. Delocalize means moving from one location to another. Okay, so this will form a positive charge metal ion. Then the delocalized valence electron will move freely between the metal structure and form the sea of electron. So this cause the metal to be conductor of electric, because sea of electron it can be moved around. So when the electric current comes in, it will push the electron to move, because like I said, the atom structure is not moving, but the electron are freely moving. Can you understand? Atom is atom, electron are released, so that's why it can freely move. So lots of that, you see there are lots of atom here, so it will create a sea of electron. Means that very, very many of electron. Okay, so with this, the electrostatic attraction force between the sea of electron and positively charged metal ion will form the metallic bond. So like this. These are the valence electron on outside. Then after that, when they are released, they will form the sea of electron, lots of electron combined together. So it becomes sea of electron, not combined, gather together. So it will from one to become a field. This is like a field. So lots of electron field will create the sea of electron. Can you understand? Can I?
Electric field
Hmm.
is a
Electron field is actually called electrostatic field caused by electron, because the moving of electron will generate current, electric current. So actually the electrostatic field are actually the magnetic field that what I call that created by the movement of atom. But it looks alike like the magnet, so that's why we sometimes call it electromagnetic field. You understand? This one you doesn't need to draw. Okay, drop down this one only. Okay. Done, huh? Good. Now let's continue. Now, the metal can conduct electricity. Why? Because of this delocalized electron in the C electron can move freely, carrying the charge from the negative terminal to the positive terminal. So that's why you remember, this is very important. For movement of electron, it moves from negative to positive, but electric current moves from positive to negative. Looks weird, right? Because at first, all the calculations are based on positive to negative, even for the movement of electron. However, under the CERN, CERN, this group is actually the center of, I forget the Center for New European Research of Nuclear. Okay, it's one of the biggest research center in the world because they have a equipment called electron accelerator. Okay, this thing move underground around 100 meter underground. The size of this is almost 100 kilometer big. Although looks a bit, okay, I can show you lah. If I'm not mistaken, I forget already. CERN accelerator. Size. Okay. Sorry, the circumference is 27 kilometer. Okay, just for the circumference, we are not talking about the whole size. So whole size is around 100 kilometer standard because you need to, there are some equipment station, all this, right? So the whole thing is around 100 kilometer, not really 100, maybe 80 something, we don't know. Okay, so it's actually called the Large Hadron Collider. Okay, it's actually a equipment that can penetrate, no, not penetrate, shoot up proton, electron, and neutron in very high speed. Because the speed is very high, you want to calculate the movement. Okay, you need a very long, and then this thing is actually cornered. So that's why the circumference, they need to move like this, so that it's long enough for calculation. Too fast because it moves within milliseconds. So you need long enough so that you can calculate the reality one. Okay. So this CERN accelerator is actually the like I said, it line down from around 50 and maximum 175 meter underground. So it's the most powerful so far, the most powerful particle accelerator in the world. The thing is here. After they do the experiment, they found out that electron doesn't move like what they do after some calculation and simulation. So they found that electron actually move from negative to positive. So this is why they still, for your current, all this we are from positive to negative, but electron movement is from negative to positive. Because by maintaining like this, you doesn't need to change any calculation. Who is so far correct. So far correct. Okay. So this CERN is actually how to say, this research center is very, we will say, is very powerful one. Why? Because they are one of the I mean, shall I say, okay, all the member inside, the researcher inside, okay, for sure is Nobel holder. Nobel holder. At least, we are talking about at least one Nobel holder, at least. He's one of the most powerful, although it's under Europe, and then do you know your World Wide Web, internet, you think is invented where? You thought it's US, correct?
Yeah.
Sorry, it's actually in CERN. They use it as their internal internal communication method for computer. And this thing already happened almost 100 years ago. So you can try to imagine how advanced they are. And this thing, I think the accelerator is around, I think it's already built since, I forget already. It built since, I think it's around quite a lot of years ago. Yeah, the first set is on 1957. And then the final one finish is 2008. So they are actually keep on revising the design, keep on. So the accelerator is actually keep on develop and use. And the first one ever is 1980s. 57 is same age as our country. So you see how advanced they are. Means that almost 60 years ago, they already use this kind of thing. See, the research will start even earlier, even more earlier. Like that. So he's one of the, I don't know lah, maybe some people say NASA is the most intelligent gathered place. But for me, I always think that CERN is actually the places where all the top-notch researchers are inside. Professors, of course. Okay, you are a Nobel holder, means that you have already done a very big breakthrough in technology and science, right? So for sure, professor is not a problem, something like that. Why I know this because my professor's professor has been the member before. My professor's professor, my sifu, like that. My sifu no. My German professor is not the member, but he said his teacher last time is actually the one inside there. So not that easy, not that easy. So if you are really try, you can try. You can make this your final destination, something like that. Okay, so this is how. So the movement of electron is from negative terminal to positive terminal along the way, and you can see and they pass through the metal atom along the way. Okay, this is why, like I said, the electron is not really affected by the position of the atom itself. They are freely move. Okay, can I? All right, jot this down.
This
Done, huh? All right, now try this one. Done, huh? All right. Now let's see the answer. So how the metallic bond form? So the valence electron of this metal atom are easily donated and delocalized. So the positively charged metal ion will be formed. And this delocalized electron can move freely between the metal structure, forming a sea of electron, and the electrostatic attraction between the sea of electron and the positively charged metal ion will form the metallic bond. Now, using your understanding of metallic bond, explain why magnesium metal with the electron arrangement of 282 can conduct electricity. Now, because there will be two valence electrons donated from magnesium atom, which will be delocalized. Then the electron in the sea of electron can move freely, carrying charge from negative terminal to positive terminal when the electricity is supplied. Right, that's the answer. Easy, huh? Now let's see the properties of ionic compound and covalent compound. Now, ionic compound is actually composed of ion. Okay, and ion in the giant crystal lattice are attracted to each other by strong electrostatic attraction force. Okay, these are the giant crystal lattice. Okay, means that there's many layers. Okay, they're like 1 layer, 2 layer, 3 layer, and it's a very big group. So this is called the giant crystal lattice. Okay, and the force, okay, and then the electrostatic force between them, the what you call the element will be the ionic bond. And covalent compound is composed of molecule only. Okay, molecules. Okay, jot down this one first. Then we see the difference between the big size, super gigantic size, and the normal size. Okay.
Yes.
Done, huh? All right, now let's see the difference between these giant molecule and simple molecule of covalent compound. Okay, maybe you need to give some space. Okay, better do like these are easy to compare. Okay, now in terms of structure, for simple molecule is small and simple structure, can be in forms of solid, liquid, or gases. But for giant molecule, it's a very large structure, and usually it exists as solids. For the chemical bond, simple bond, okay, simple molecule, it has a strong covalent bond between the atom in molecules, but weak when there was attraction force between the molecules. Now, for giant molecule, it has a strong covalent bond between the atom in the molecules, but no van der Waals attraction between the molecules. Because this one is not the gigantic, it's just a big one. Only. Large molecule, the attraction force actually is very weak. So when you become bigger, the van der Waals forces will even weaker. Only when there's many of them, gigantic structure like diamond, then yes, you have a very strong, because actually is a, let me show you your, sorry, let me show you how it looks like. The, we call the grain structure. Okay, when you try to enlarge the vision of the surface of the like metal, for example. So you have found that they are like pieces like this, right? So you see like this one is like a pieces one, right? These pieces are actually one giant structure. It's a giant structure, and when there are a lot of them, like diamond, like diamond. So the giant structure of diamond. You see, the structure is already become very, how to say, very compact already. So when very compact, so the when the Waals forces now go very near, correct? Because it's compact means that the atom and atom is very near to each other, right? So when it's very near to each other, the van der Waals forces now become very strong already because they are very near. Unlike the giant structure like this one, the giant structure like this one, you see, is actually far away. See, far away. So that's why the van der Waals forces are only affected in near only. So when far away, so no van der Waals forces. Can you understand? Okay, so it's different. Gigantic and giant molecule is different. Giant molecule is considered as large molecule. Okay, all right, jot this down. Learn, okay, now let's continue. So for simple molecule, because the bond is weaker, so they have a lower melting point and bonding point. Because the bond is weak, so it requires less energy to break the bond. Okay, so no need so high temperature. All right. Then for the giant molecule, it has higher melting point and boiling point because it has a stronger covalent bond. Okay, so the example is like the covalent bond between the hydrogen atom and the van der Waals between the molecules of hydrogen. Okay, while for this one, silicon, this is the silicon at the center, the dioxide at the side. So they are bonded by the what I call, they are bonded together by this what I call that, the covalent bond. Okay. Hello? Okay, so jot this down. This one, it doesn't like, no need to draw this. Maybe just 1, 2, 3, then enough. No need like draw until this what I call, this is for you to understand only.